Okay, let's go over team challenge number 6, the titration curve. A lot of people are struggling with this concept, so I'll go over it pretty slowly. The first thing to do whenever you're looking at a titration is to remember that you're not usually doing 1 full liter of 1 molar weak acid or weak base. Usually you're doing a smaller volume and a lower concentration. So in this question, it's 50 mils of a 50 millimolar weak acid. So what we have to do here is figure out how many moles of that weak acid we have in the beaker at the start. This is going to be our number of moles per equivalent. So this is 0.05 liters times 0.05 moles per liter, which is equal to 0.0025 moles in the beaker. And this is how we define an equivalent. So this is how many moles there are in an equivalent, 0.0025. Now another thing that's really good to figure out and makes the question really easy is to realize that we're titrating with 0.2 molar HCl, so it's good to know how many milliliters make up one equivalent. So I can say, all right, if I have 0.0025 moles per equivalent, and I have a solution that is 0.2, sorry, that's supposed to be 2, 0.2 moles per liter of strong acid, then I end up with 0.0125 liters of strong acid per equivalent, which is 12.5 milliliters per equivalent. Okay? So that makes doing this next part of the question, filling in the table, really easy. Because I just say, okay, 0.05 equivalents, which is 0.05 times 12.5 mils, is equal to 0.625 milliliters. So I add 0.625 milliliters, that's 0.05 equivalents, and we had a measured pH of 7.94. So I'll fill in the table here for the first half, and you can figure out the rest on your own. All right? Now you actually have to plot a titration curve, and you have to figure out what the pKa's are. So to plot a titration curve, it does say here that there are 2 pKa's. So that means I need 2 equivalents. So I have put 2 here on my x-axis, and that is equivalents. Note spelling, please. Of, in this case, HCl added. All right? And that I am going to plot versus pH. I actually don't need to go that high in pH for this question. My y-axis is going to be labeled pH because my top values are only around 8. Now I can plot the points that are in the table. Okay, it's one thing we're going to do. So 7.94 at 0.05. Let's put some ticks in here. 0.1, 0.2, 0.3, 0.4. So 0.05 is here, and it's at 7.94 right there. I've got 0.2 and 7.26, 0.2, 7.26, and I've got 0.4 at 6.84 somewhere in here. I've got 0.6 at 6.48, somewhere in here. And I've got 0.95 at 5.38, so somewhere in here. All right, then I have the other, the next pKa to work on. I've got at 1.05, I'm at 4.61, somewhere in here. 1.15 is at 4.08. It's getting pretty sketchy on my estimations here, but bear with me. Let's see. So somewhere in here, I have 3.61. 1.55 is 3.24. And finally I have 1.85 out here and 2.58. So somewhere in this neighborhood. I got a bunch of points. I would really like to put the pKa's on there, but I don't have them right now, so I have to figure them out. So let's see how we could do that. We'll take any point here, and we'll say, all right, let's take this point for instance. All right, at 0.6 equivalents added, I was at a pH of 6.48. So I know that pH equals pKa plus the log of A minus concentration over HA concentration. I know I started as fully A minus, or 1 as A minus, and essentially 0 as HA. After adding 0.6 of H plus, I would have 0.4 left as A minus and 0.6 as HA. These two numbers have to add up to 1. It's like a ratio. What percentage of the total equivalent did I move over from A minus into HA? So adding 0.6 equivalents of H plus, they got together with 0.6 equivalents of A minus to make HA and left 0.4 as A minus. So I can now just put this back in. The pH was 6.48. Rearrange this to solve for pKa. There's a log here, sorry, it's missing. 6.48 minus the log of 0.4 over 0.6. So I just rewrote that, and that gives me a value of 6.66. So I can go in here and say, okay, I'll put my pKa on here at 0.5 and 6.66. All right, I can do the same math with the other side, and I come out with a pKa there of 3.33. I always see some bad plotting here. Okay, so I have my two pKa's, which I've solved mathematically, and I could derive from the graph, and I have my graph, and I can connect the dots in a roughly smooth curve. We're going to have a bit of a dip down there, roughly smooth, and it's going to drop off again. So that is how we generate a titration curve. We can manipulate the numbers back and forth in any different direction if we understand the concepts here. And from this case, we were able to mathematically determine the pKa from the data given. Sometimes you might have to calculate the pHs given pKa's. That's a different story. You would use the pKa and the ratio to determine the pH. It's just a different part of the equation that's missing. So that's how you do titration curves.